All right. Today is September 19th. All right, today we are looking at non-rigid transformations of parent functions. Yesterday we did rigid transformations, which means that we took our parent graph and we just slid it left, right, up, down, or maybe flipped it vertically. Today we are taking our parent graphs and starting with our basic shape. That shape can be stretched taller or compressed smaller, and we can do that vertically. We can also do that horizontally, where we pull it apart horizontally or smush it together horizontally. And so I'm going to do things a little bit differently today because I'm going to be doing things numerically today with ordered pairs. So we're going to look at the transformations at the ordered pair level. Instead of just sliding a whole graph, it's much harder doing these non-rigid transformations. Actually, just looking at the ordered pairs is pretty helpful. So to get started here, number one, what shape is that function? A V. Very good. So absolute value V. And we know that the three ordered pairs for that absolute value V pass through -1, 1, 0, 0, and +1, 1. And I encourage you to write down those ordered pairs because, as I said, I'm going to be using those ordered pairs, and we need those basic ordered pairs, the parent function ordered pairs to graph these things. Now, yesterday I talked about inside versus outside. And when things are on the inside, do they affect X's or Y's? X's. And if things are on the outside, they affect Y's. Well, the nice thing is that goes, you have X values and Y values in an ordered pair. Inside, outside also is alphabetical. And so if there's a number on the inside, it's going to affect X values. If there's a number on the outside, it's going to affect the Y values, just as a way to sort of keep things straight. So when I look at number 2, the 4, is it on the inside or the outside of the function? Outside. Does that affect X's or Y values? Y values. Y values on outside, it affects Y values. What do you think it's going to do to those Y values? Multiply by 4. That's exactly right. So I'm going to use a little bit of notation here. The X is going to stay exactly the same, but my Y values are going to be multiplied by 4. 4 times the Y. So what happens to these blue ordered pairs? What do they morph into? -1, 1 is going to change into -1, 4. What did I do? I multiplied the Y coordinate by 4. 0, 0 is going to change to 0, 0. It doesn't change. That was a trick question. All right. And 1, 1 is going to change into 1, 4. Very good. The X stays the same. The Y gets multiplied by 4. And once we do that, then we can plot those points. That's kind of the nice thing about having ordered pairs. You just plot them and you're done. Now, I can do it graphically, but it's kind of tricky, which is why I always just use ordered pairs. I've been doing this for 20 years. I know how this works. What is happening here is we're taking our original Y value, which right here is at 1, and we're multiplying it by 4. You can see how it's sliding vertically. It's growing vertically. 1 times by 4 becomes 4. This is called a vertical stretch. This is called a vertical stretch. Now, I like to think about this. It's really important that we understand it's a vertical stretch. A lot of students look at that and they think that our graph just shrunk horizontally. It got narrower, right? So that's what a lot of students think is going on, and I just want to mention that's not what is happening. The Y values are growing by a factor of 4, Okay, so this is called a vertical stretch by a factor of 4. Let's see, number 3. Is the 2 on the inside or the outside? Inside. Does that affect X's or Y's?
X.
Okay, for all the money in the world, what's going to happen to those X values?
You're going to multiply by 2.
Wrong. Good, I can save my money. Okay. Everything with X is inverted. When we do translations, it was X minus 3. It moved it to the right 3. X plus 3 moved it to the left 3. It's always the opposite of what it looks like. It's inverted. This is not multiply by 2. You have to invert it. Flip the fraction. We are not multiplying by 2. We are multiplying by 1/2. All right? Always, always. Everything with X is inverted. You can talk about Y. I'll talk about that later. Okay. So my X coordinate is changing, but my Y coordinate is staying the same. So going back to these blue ordered pairs, -1, 1 is going to transform into -1/2, 1. Very good. 0, 0 stays the same. And 1, 1 is going to turn into 1/2, 1. The -1 times 1/2 would be -1/2. All right, so graphically here, when I'm looking at my original blue ordered pairs, these X values, are they getting bigger or smaller? Smaller, right? We're multiplying by 1/2. That's going to make numbers become smaller. We're taking this X value, which is at -1, and multiplying it 1/2, which is going to slide it closer, if you will, to the Y-axis. These X values are shrinking closer to the Y-axis. This is called a horizontal compression. We are sliding those X values closer to the Y-axis. This is a horizontal compression. So I'm just going to put H compression. So horizontal compression by a factor of 1/2. We're multiplying by 1/2. That's what those X values are changing by. We're going to skip number 4 for now because my graph will be too congested. All right, let's do it down to number 5.
Well, so before, would it be multiplying the X by 3? Or no, 1/3?
1/3 X.
Multiplying 1/3.
3Y. Yeah, so this one would be the X. Remember, you've got to do the inverse, which would be 1/3 of the X coordinate. The Y is always straight up exactly what it is. Whoops, can't see that there. If you were doing that, that's the notation I would write for that. But I'm not going to graph that one right now. All right, number 5. Here we go. Number 5, what shape is that parent function? Parabola. Very good. And again, those same 3 points. But I'm also going to include 2, 4, just so we can see what happens to that value as well. So there is my lovely parabola. So that passes through -1, 1, 0, 0, 1, 1. I'm also going to include 2, 4, just so we can see what happens when we have numbers other than 1 and 0. All right, looking at number 6. Is the 1/2 on the inside or the outside? Outside affects X or Y's? Y's. Outside affects the Y values. The X is going to stay the same. What's going to happen to the Y values? Multiply by 1/2. Everything that affects Y values is exactly what it looks like. X's that mess everything up. All right. So looking back at my original ordered pairs, what's going to happen to -1, 1? -1, 1/2. 0, 0 stays the same. 1, 1 is going to turn into 1 1/2. Very good. And 2 4 is going to turn into 2 2. Very good. Half of 4 gives you the 2. Half of 4 gives you the 2. Again, we can plot these points. This is affecting the y coordinates. The y is everything vertical. So this would be called a vertical stretch or compress.
Compress.
Compress. Why is it a vertical compression?
Because the flies are changing.
Are they getting bigger or smaller?
Smaller.
Smaller. So you can see what's happening vertically. Our values are getting smaller. They're lowering. 0 0 stays the same. 1 becomes 1/2, and 4 becomes 2. And you can see how it's sliding closer to our x-axis. So it's a vertical compression, like a spring compressing. Oh, all right. Number 7. Is the 1/3 on the inside or the outside of the function? Inside. Inside, which is going to affect x's or y values? X's. What's it going to do to those x's? Multiply by 3. 3 times the x coordinate. The y coordinate stays the same. All right. Remember, everything with x gets inverted. You've got to flip the fraction. All right, so here we have, what does -1 1 transform into? -3 1. Very good. 0 0 stays the same. 1 1 is going to become 3 1, and 2 4 is going to become 6 4. All right, -3 1. 0 0 3 1. What is this called, do you think? Stretch. Horizontal or vertical stretch? Horizontal. It's a horizontal stretch. Mainly because we're changing the x coordinate. The horizontal axis. The x is the horizontal axis. If we're multiplying by 3, those numbers are getting bigger. That's stretching. So horizontal stretch. Horizontal stretch by a factor of 3. All right, number 8. How are you doing so far?
I kind of suck at it.
Melly. Oh, what is it called? So it's a vertical compression. Vertical compression by a factor of 1/2. All right, on number 8. Number 8's interesting. How many transformations do we have? 2 transformations. Very good. And so I'm going to look at the inside here. Inside with x, what do we need to do to our x coordinate? Multiply it by 2. 2 times the x coordinate. Then the negative is on the outside, which is going to affect the y values. What do we do to those y values? I think I heard make them negative. Okay. Multiply by -1. So it's -1 times the function. We're going to take the y values and multiply them by -1, which I'm sure is what you meant, but I don't want to say that that's make them negative, because it's actually make things the opposite. Okay. All right, so now we're transforming both the x and the y coordinate. -1 1 is going to turn into what? -2. -1. Very good. 0 0 stays the same. 1 1 is going to turn into what? 2 -1. 2 times the x is 2. -1 times the y is -1. And 2 4 is going to turn into what? 4, negative 4. Very good. 2 times the x. 2 times 2 is 4. And then negative 1 times the y. Nope. All right, I'm going to plot those. Negative 2, negative 1. 0, 0. 2, negative 1. So if you were going to describe this one with words, upside down what? Upside down, a frowny face.
Spider.
It's upside down
Spider.
How would you describe the 2x? What's happening with words? It's multiplying the x value by 2. That's going to be a horizontal stretch. And then if we're multiplying the y value by a negative, what's happening? What's that called? A vertical reflection. Yes. So this is a horizontal stretch by a factor of 2 and a vertical reflection. A vertical reflection over the x-axis, if you want to write that out really specifically. Not right now, you don't have to, but it's something you'll have to talk about tomorrow, so. All words you should know. Okay, we're just gonna do these last 4 and then I'm gonna go ahead and let you just work on the other side. Number 9 is the square root of x. What shape is that? Swoop. Square root swoop passes through 0, 0, 1, 1, and 4, 2. 0, 0, 1, 1, and 4, 2. All right, number 10. How many transformations are there?
2.
2 transformations. What's happening to the x-coordinate? Multiply by 1/2. Again, flip that thing with the x. 1/2 times the x. And what's going to happen to the y-coordinate? Times by 3. 3 times the y. 0, 0 stays the same. 1, 1 is going to turn into what? 1/2, 3. Very good. 4, 2 is going to change into 2, 6. 2, 6. All right. So 0, 0. 1/2, 3. That's really interesting. And then 2, 6 is way up here. What's happening to this graph? It's a vertical stretch and also a horizontal compression. Yeah, so everything's sliding in. So it's compressing horizontally and it's stretching vertically. Number 11. Good. I'm hearing the right things.
Do we have to put the horizontal projection on that on the back of this?
You don't have to write it. No. I'm hearing mutterings on number 11. So there is like a negative 1x in front. So what are you thinking that's the negative x? Yeah. That negative 1 is affecting our x coordinate. And if you think about flipping it, well, flipping 1 just is still just 1. So it's, yeah, negative 1 times x. Does anything change with the y?
No.
No. So what's happening to our x coordinates? Yeah, 0, 0. 1, 1 is going to become negative 1, 1. And 4, 2 is going to become negative 4, 2. So what is this called if I'm graphing these this way now? Yeah, reflection over the y-axis. A horizontal reflection. So if you imagine, like, it was originally here, and it's flipping. So, I say that. Okay, so most books will call it a reflection over the y-axis. Okay, you're thinking it's a reflection over the vertical axis. Okay. That, yeah. I won't use that word. Okay, last one here, and then you guys can. Number 12. What are we doing in number 12? Multiply x by negative 2. Negative 2 again. All you're doing is flipping the fraction. Not changing the sign. It's flipping the fraction. So 0, 0 stays the same. 1, 1 is going to become negative 2, 1. And 4, 2 is going to become negative 8, 2. 0, 0, negative 2, 1. What is this called? How would you describe this one? Horizontal stretch, yeah, reflect and stretch. Horizontal reflect and stretch by a factor of 2. All right, very good, ladies and gentlemen. Please come ask me if you have any questions. You can go ahead and just work on the other side. You don't need to do the last grouping there.
Makes us good now.
On the side. All right.